So here's our next example. We'll be factoring this cubic. So just like before, the last number, if we looked at all the factors of the last number there, we'd have plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. So those are all the numbers that would divide into 6. Now, because there's also a 2 out front, we're going to call those factors q. We would need all the factors of that 2 as well. So that's plus or minus 1, plus or minus 2. And if we wanted a list of all possible factors that we could possibly have to plug into this expression, what we actually have to do is we have to write all the p's over the q's. So first, all the p's over 1 will just be the p's again. That wouldn't change anything, because dividing by plus or minus 1, you get back your original. Okay, next dividing by 2. So plus or minus 1 divided by plus or minus 2 would be plus or minus a half. 2 over 2 would have been 1, so we already have that. 3 over 2 would be 3 halves. And then 6 over 2 would have been 3, which we already have. So all the possible numbers that you could possibly have to plug in are in this list right here. Okay, and that's just the factors of the last number divided by the factors of the first number. Now, you don't need to do this step. You can just start trying numbers. Okay, so you could just look at the 6 and just start trying to plug in numbers that divide into 6. And chances are that will work. If you wanted to have a full list of numbers, though, this is how you would do it. So I'm going to let this be called f at x. And we need to find f at some number equaling 0. Okay. So you're just going to take these numbers, plus and minus them, one at a time, plug them in until you get a number that causes your function to be 0. Okay, so if we were to try, for instance, -1, then you would get -2 minus 11, that's -13, plus 7 plus 6, that would be 0. So because f at -1 equals 0, that means that x plus 1 is a factor. Okay, and I don't need to see all the steps of you plugging in the numbers, because you're going to be doing that probably on a calculator. Okay, so now that we know what the factor is, we're going to divide out that factor. So using synthetic division is the easiest way to do this. Remember, we just write our coefficients up top, add down, multiply up. Add down, multiply up, add down, multiply up, add down. Okay, and you should always end up with that remainder of 0. And the quotient here would be 2x squared minus 13x plus 6. Okay. So we're going to rewrite our f at x as the divisor times the quotient. And then, last but not least, we still have this quadratic, which we need to factor. Okay, so you can do it using decomposition or whatever method you learned at your school to factor this quadratic. So I can do it off to the side here. If you're doing a long method, so 2 times 6 would have been 2 numbers that multiply to 12 and add to -13. So that would be -13 and -1. Sorry, -12 and -1, I should say. Okay, I can pull 2x out of the first bit. Pull a -1 out of the second bit. That's a minus there. And I get x minus 6 times 2x minus 1. Okay, and that's just a little aside. So going back to my original function here, that quadratic is 2x minus 1, x minus 6. And there we have our fully factored cubic. So the cubic was 2x cubed minus 11x squared minus 7x plus 6. And when it's factored, it's equal to x plus 1, 2x minus 1, x minus 6. And that is our final answer. What you'll notice here is all of these roots, the -1, the 1/2 that you would have gotten from this bracket, and the 6, all of them do appear in our original list, right? -1, the 1/2, and the 6. So you could have actually started with any one of those three numbers, and you would end up with the exact same answer. Okay, so you won't always have the exact same method as somebody else in the class. It just depends on which number you find first that makes your function 0. So let's try this last example. This time it is a quartic, so a degree 4 function. Okay, and I'm definitely not going to write out all the possible factors of 40. We're just going to start trying some numbers. Okay, so I'm going to let f of x equal this quartic. And then I would recommend that you guys pause the video and find a number that makes this quartic 0. Start with the low ones. Right, start with plus or minus 1. And then there's 2, there's 4, there's 8, there's 5. All the numbers that divide into 40 plus or minus. Okay, so pause the video, try numbers until you find one that works. Okay, so I found 2. F at 2 does equal 0. And what that means for us, it means that x minus 2 is a factor. So now we're going to divide it out. Okay, so I'm going to put 2 there. I'm going to do my synthetic division. So bring down my 1, multiply by 2. Add, multiply by 2. Add, multiply by 2. Add, multiply by 2, add. So I have my remainder of 0, which is exactly what I wanted. I have a constant term of 20, an x term with a coefficient of 24, an x squared term with a coefficient of 9, and an x cubed term with a coefficient of 1. So I can now write out my f at x as my divisor, x minus 2, times x cubed plus 9x squared plus 24x plus 20. And we're not done yet, because if we look at it, we'll notice that we still have a cubic that we need to factor. Okay, we don't really have a huge shortcut on how to factor that cubic, so what we're really going to have to do is we're going to have to take that cubic and we're going to have to do this whole factor theorem thing again. So I'm going to let g of x equal that cubic, and once again we're going to have to find a number that makes that cubic equal to 0. And this time we're just working with the factors of 20. So I found that -2 works, which means that x plus 2 is a factor. So here I've set up my synthetic division with the coefficients of g and my value of -2. So I'm going to bring down the 1, multiply by -2. Add, multiply by -2. add, multiply by -2, add. And now we have that quotient of x squared plus 7x plus 10 with a remainder of 0. Okay. So going back to f at x here, remember we had the original x minus 2. And then we had the g of x part. So g of x is composed of this x plus 2 bit and this quadratic here. And then now that we have it as a quadratic, we don't need to do factor theorem a third time because we know how to factor that quadratic already. It'll factor into x plus 2 and x plus 5. And because we have two x plus 2 brackets, then you should rewrite that as x plus 2 all squared, because we do want everything to be fully simplified. Okay. So there we have our factored quartic function. So because it's a quartic, you would expect in the end to get 4 roots or 4 brackets, which we did. If it had been a quintic, so degree 5, you might have had to do factor theorem 3 times. Okay, so you would just keep doing factor theorem and that synthetic division step until you got it down to something that you could factor using what we've already learned in our previous courses. And that is the end of this example. So you guys can now begin doing your homework.